now is. So Andy, it's a real honor to have you, and I give you the floor.
Thanks, Professor Serrato, and thanks to everybody for tuning in on your day off. I will make it entertaining, and I'm happy to follow up with you about anything that you want to talk about with regards to what we're doing. I'd also like to thank the University of New Mexico and the other faculty, staff that made this possible. Thank you very much. And I hope I don't disappoint in this story I'm about to tell you. All right, let's see. Set this up. All right, can you see my screen? Thumbs up? Yeah, okay, great. All right, so I'm going to tell you a little story about policy, and I'm going to leave it up to you to make your own decisions about whether or not policy is enough to protect human health after disasters. My research team at the University of South Alabama and then at Purdue University, and then the colleagues that I worked with, focus on helping people understand chemical contamination and decontamination of infrastructure. So this could be your buried water systems, it could be building plumbing, and we do training, we do lab testing, we do field work, we do all sorts of things. And this was partly inspired by my work with the US Army, which I did for 3.5 years as a civilian. And I've had a lot of opportunity to work with a lot of great organizations. And these organizations here are just some of them that have influenced who I am today and where I am and what I'm about to show you. So first, before we get too deep into this, what's the definition of policy? Policy is really a course or method of action selected from alternatives given conditions. And so when you're faced with a challenge, you may find yourself weighing different options. And you may say, okay, well, should I do this, A, or should I do B, or should I do C? And so a policy is basically set when you make that decision. Now you can change your policy in the next time you're faced with that decision, do something else, but you're basically choosing some form of policy. And that may be, for example, if your water smells funny, do you test it or do you not test it? Well, if you choose not to test it, then that is by itself a policy that you've just established. And it doesn't have to be a formal document that somebody can go to in a library to read as a policy. There are informal policies. And in drinking water infrastructure, we try to avoid ambiguity. We try to, under the Safe Drinking Water Act, federal law, establish what is expected in terms of water safety for public water systems or water systems that serve, more than 25 people or more. And for large systems like Albuquerque or, Dallas, Texas, or Sacramento, California, they might have miles and miles, 1,000 miles of piping. And that water is brought from a source, put into the piping network after it's treated, and then delivered to buildings, commercial or residential. And so we have prescribed requirements for testing and sampling and where you sample and what you look for, and to try to make certain that the water that's delivered to that property doesn't harm people when it gets there. But we also have this other subset of the population that receives water from wells, private wells. And private wells are, you could have a school building with a well on property. And so the people in the school aren't necessarily regulated as a public water system. They may just get their water from this private well, a school of 10 or 15 people, or it could be more. We have private wells, private homes, we have ranches, we have all sorts of different types of situations where people around the country receive their water not from public water systems, but from private wells. And both public water systems and private well owners are faced with disasters sometimes. And if you just look around the United States, the lower 48 states here, natural disasters affect thousands of communities in the US each year. This prompts microbial threats, E. coli contamination of the water, bacteria contamination, or chemical risks. And these are where you can have chemicals making their way into the pipes. and making the water unsafe and being delivered to a user. So these are really significant, and these can be brought on by natural disasters. Chemical spills is another way that water can become unsafe for public water systems and private wells. Mostly for public water systems because you're dealing with lakes and rivers, and you can have chemical spills. These could be petroleum products, or these could be other chemicals. Or one of the stories I'm going to tell you about is a chemical that was spilled in West Virginia's water supply that made 300,000 people turn on their taps, and the water smelled like black licorice candy. But pivoting back to the West Coast, California wildfires that are happening today have impacted 4 million acres this year, and that's significant. Most of the land is federal land, and we're having hundreds of 1,000-acre fires. 4 out of the 5 largest wildfires in California occurred this year, but the most destructive fires, the deadliest and most destructive fires, occurred in 2017 and 2018. So there is just a tremendous focus right now on wildfires out west, and there should be, because wildfire season still goes until about December, and we expect to have potentially more fires start because of the climatic conditions and because of just how dry the season has been. And it's not just California. Many different states are undergoing these issues, but you can also have wildfires in other parts of the country, not just out west. So a couple of weeks ago, Vermont was media was doing a lot of stories about how the Forest Service up in Vermont was very concerned because they've had a very dry season. And you can have wildfires in North Carolina and elsewhere. Just right now, we're hearing a lot about the American West. And so now that we've kind of talked about disasters and we've talked about drinking water infrastructure, when those two combine, especially wildfires, you can have widespread chemical contamination. And so after the Tubbs fire in the city of Santa Rosa in 2017, there was boil water advisory issued. And boil water advisories are issued because if you have a piping system and you lose pressure, that loss of pressure may allow organisms and dirt to come into the pipes. So when they repressurize it, now you have water with dirt in it, and that may be harmful. So, so a boil water advisory was issued in the city of Santa Rosa after the Tubbs fire because they lost pressure. Well, after 3 weeks later, somebody called up the city and said, "Hey, we have a strange smelling water at my house. Can you come out and check it out?" So the city had their own commercial lab, and they did testing. And what they found was that benzene and some other chemicals were present. Benzene is not supposed to be in the drinking water, and it definitely wasn't present in their source water. So they thought that it was from the fire. So what they did is they created this thing called a do not drink, do not boil advisory. And that hadn't been done before, but they came up with it. And that basically said, don't boil the water. We told you to, but don't do that. Because if you boil it, whatever's in that water, these VOCs, volatile organic compounds, will then off gas into the air and you'll be exposed to it. And so over the next year, the city of Santa Rosa did extensive testing of 5.2 miles of their water system and found very, very, very high levels of contamination in some places, in other parts, not so much. The response and recovery was overseen by the state of California's Water Board and the US EPA Region 9 office. So they basically were walking along for the ride and in approving all the actions that were being taken. The testing revealed multiple VOCs, not just benzene, several others above safe limits, semi-volatile organic compounds, tentatively identified compounds, and a number of other materials in the water. What was really interesting was that the city of Santa Rosa realized that when they flushed out the contaminated water and then brought in fresh water, if they left that fresh water there and they went back, that water would then be contaminated. And that was because these chemicals had adsorbed to the surface of the pipes and the meters and the valves and were desorbing into that clean water, right? Concentration gradient. What also happened was they realized time was really important. Like if they just put clean water in there and left the clean water in there for, you know, a day, they would find a lower concentration of, say, benzene in the water than if they left that water in the pipe for 3 days. And so their ability to detect contaminated infrastructure was based on leaving the water and soaking it inside the infrastructure to see if it was damaged. They decided basically because of that dynamic situation, California has a limit of 1 part per billion of benzene in the water, and their detection limit for their lab tests was 0.5. So they said, look, because there's just so much unknown, if we find benzene above 0.5, we're going to assume that that infrastructure is contaminated and we have to do something about it. So they called me about 3 months into the response, and they said, you know, how much longer are we going to have to flush this system? And what it turned out was that they thought they could flush everything away, but they had a lot of plastics and the contamination basically went into the plastics, and you're looking at, you know, months to years potentially of just running water to get it out. So they started pulling stuff out of the ground and replacing it. But during their testing, they found up to 40,000 parts per billion of benzene in their water. And just to give you some perspective, the RCRA, Resources Conservation and Recovery Act, hazardous waste threshold for a characteristic hazardous waste is 500 parts per billion. Okay, so they had some seriously contaminated water. And that leads us to Butte County, California. So in 2018, this beautiful area in the Sierra Nevada mountains, which is north of Sacramento, was rocked by a fire. And this fire was called the Campfire, and it wasn't created by somebody camping. It was created because it started near a place called Camp Road. At about 5:30 in the morning, Pacific Gas and Electric called up 911 and said there's a fire in this town called Polga. Well, over the next 3 hours, that fire was moving rapidly through this heavily wooded area with homes in that area too. And it was basically jumping pine tree to pine tree and moving through with these tremendous winds. I think it was like 80-mile-an-hour winds. And about 8:03, the sheriff called for evacuation of the area affected. And about 8:24, the 911 operator told people as they called, nobody can help you, you just need to leave, because people were calling for help. Later, what happened was that the routes were blocked. People couldn't get off the mountain. You had about 30 or 40,000 people told to evacuate at the same time. There was very limited roads. If you've ever been back in the mountains, you know, we're not talking about 6-lane highways. We're talking about 2-lane roads in one direction. So there's a good Netflix documentary that's worth checking out. It gives you some perspective about what it's like to flee this fire. The fire was moving about 60 football fields a minute. And about more than 33% of the population never was told by the emergency evacuation system to evacuate. So this Campfire was just a completely different scale and disaster. So it's not the largest by area fire, but it basically rolled through entire urban communities. In the town of Paradise, you can see here in the yellow block, is completely pink. And that is the fire started down here, it moved north, it moved south, and rolled through and stopped down here by Chico. Okay. And this all happened in about 3 hours. Okay. So we're talking about fires nowadays that are burning for weeks. This basically happened pretty rapidly. This picture is a zoomed in picture of the town of Paradise. Typically you have black dots on your maps that show where structures are. The red dots indicate a damaged or destroyed structure. So there was about 12,000 buildings that were destroyed in a matter of hours. And what was happening was the fire was jumping tree to tree, but it was also jumping structure to structure, and then embers were going down because of just the density of the area. So about 1,500 people remained in the area after the immediate evacuation. Now, getting back to water and engineering, so public water systems, there were a couple in the area, excuse me, more than a couple, there were several in the area, but the two main ones were called the PID, or the Paradise Irrigation District, which is a water system, not an irrigation company, in the Del Oro Water Company, And they own, that's a private entity, and they own 5 other systems in that area. So they were all impacted by the fire. And there were a number of smaller systems too. And basically they issued boil water advisories. So they, just like after the Tubbs fire, they told everybody, boil your water. We may have lost some pressure. There was also private wells, about 2,400 private wells in the burn area that were affected too. And just to kind of walk you through a little bit of what happened over the course of several months, here's the Delaware Water Company, DOWC, and here's the PID, the Public Water System. And what we have is on November 9th and November 11th, both utilities issued boil water advisories. The private water company lifted their advisory, and then for some reason, they decided to take water samples and look for benzene in their water. They waited 2 weeks to get the results because they didn't realize that you can get water testing lab results back faster than 2 weeks. You just have to pay more money. And they found benzene was present in their water at above safe limits. Well, the PID, the public water system, heard about this and immediately issued a do not drink, do not boil advisory. The Delaware Water Company didn't. And so the next day, the state of California issued a press release and said that we know that PID has this advisory in place, but we think that if the water doesn't have an odor, it's safe. And they put that out in a press release. That's policy. And that's not true, but that's policy anyways. And so on January 9th, the Delaware Water Company, because there was confusion with its customers who only lived a mile away from Paradise Irrigation District, reaffirmed to its customers that the state didn't tell us to do anything with issuing advisory, so you can use the water as long as it doesn't stink, everything's fine. On the 11th, the PID had conducted testing and found benzene present. So now you had Delaware Water Company and you had Paradise Irrigation District. They had contamination, and the state went public and said, we approve of both policies. These are both acceptable. Then in late January, the state found benzene at over 2,000 parts per billion in the Paradise Irrigation District system. On March 5th, the state issued a press release saying that there was never ever contamination found in Delaware Water Company, even though the state actually did the testing and had the data. So we notified them. About 12 hours later, they issued a correction and said, yes, it used to be there, but it's not there anymore. The state tries on March 9th to force the Paradise Irrigation District through what's called a permit amendment to only look for benzene in their water sampling, to sample all their homes and use a 12 to 48 hour stagnation time. We objected, they pulled it back, and then the county health department had enough and issued a county-wide water advisory that applied to Delaware Water Company, the PID water systems, private well owners, that said, don't drink or use the water, don't take baths in it because we don't know what's in it, and don't even try treating it yourself because we don't really know the concentrations and chemicals that are in the water. March 22nd, the California Department of Health released a study showing that they took contaminated water from Paradise, they brought it to people that are state employees, those had them smell it, and people actually had adverse health effects. They reported throat irritation and other symptoms. So they said, odor is a cause of many compounds and you shouldn't be smelling the water to determine if it's safe. On April 10th, the state came out again and said, we did find more benzene in the Delaware Water Company, but you can use the water. And then April 29th, the state toxicologist for California released their analysis that showed 26 parts per billion of benzene poses a short-term risk to children. It actually will cause blood chemistry changes. And so what I show you this figure here is that there are 2 utilities in the same state with the same fire, and there were different policies allowed to happen or issued by the same entities. So in February of 2019, we got invited to come in to help a number of different organizations, the emergency services, the county health department, FEMA, PID, the utilities in the town. And we flew in and basically got them all in a room and showed them how to get through this process. That was early on. They had 50 water samples 3 months after the fire. The city of Santa Rosa had 8,300 water samples 1 year after the fire. And at that time, on the same timeline, the city of Santa Rosa had like 400 samples, while Paradise only had 50. And so there is a methodical way to go through this, but the policies that were being created were on the fly. It was a bunch of people who didn't have any experience about really anything that they were talking about in terms of disaster response, in having consensus, this sounds good enough, and then moving forward. So they didn't have any like external experts giving them feedback on this. Now, for the engineers, when we talk about water systems, Paradise water system basically started at the top of the mountain up here. Their treatment plants and their source waters, their lakes, were not affected. So the only thing that was damaged was their distribution system. And these dots here on the screen are standing structures, so commercial buildings or homes. And the reason why there's only really a few of them is because all the others were destroyed or burned down. They had about 172 miles of their water system, about 10,600 service lines. And so you could think about 10,600 water meters in their building. And the damage was extensive. What we saw here is at the top is 2 high-density polyethylene plastic service lines. In the middle picture at the top, that is because plastic melted, flowed down the pipe, and cooled in place. So that's like a plastic plug inside that plastic pipe. You can see on the right, the plastic pipes kind of melted in the middle and bubbled. The water meters were in the lower right there. The middle one is a plastic water meter. The one on the right is a metal and plastic water meter. 90% of their water system depressurized for hours to weeks. I mean, they were fixing hundreds and hundreds of leaks. And there were about 11,000 pictures like this, where the only thing that was left was a chimney. In terms of the scale of contamination, what was found was after the Tubbs fire, as I mentioned, they found 40,000 parts per billion of benzene, but they also found other chemicals using the methods that they applied. The Campfire found many of the same chemicals because they used the same methods, and the levels exceeded short and long-term exposure limits. And so this information is available. You can click on the AWA Water Science Journal and read more about it. So the big question is, where did it all come from, right? Like, okay, so we have contamination and we're getting it out, but where is it coming from? And the answer to that is nobody knows yet. The fact of the matter is there's 3 primary sources that we believe. The first one is plastic gaskets and pipes that are in the infrastructure getting heated and decomposing in place and leaching chemicals into the water. Another theory is, well, we know that when you burn plastics, you release VOCs and SVOCs, exactly the same ones that were found in water. We also know that when you burn structures like buildings and even vegetation, you get exactly the same VOCs and SVOCs going into the air. So it's likely one or all of these theories as the source of the contamination. But one of the issues here is that there are primary sources, but then once that contamination gets into the water system and inside that pipe and it flows down the pipe, it can contaminate infrastructure that was fine before, that wasn't thermally damaged, that was clean. And then that can become a secondary source. And that is what's so difficult with responding to these types of disasters. There's a bunch of science that can be applied after disasters, and there really isn't much that is right now, however. And so the way that it happens is we kind of force this into the decision-making process is the plastic service lines, the pipes that convey water from the water meter to the house, or a service line that conveys water meter to the water main, were generally plastic. And so one of the issues is those act like sponges and take up these VOCs. And the question was, and we were asked this by Cal OES, how long is it going to take for us to flush that? And how much water is it going to take? And so with US EPA Office of Research and Development, we work with them to come up with estimates, based on chemical diffusion through plastics and their models. And they estimated for a pipe where you had 100 parts per billion of benzene in the water, it would take you over 286 days of constant flushing of that 1-inch diameter pipe at 2 gallons per minute, 24 hours a day, every day of the year, to get decontamination. And why that matters is, one, we use science, and it worked, to estimate and give us some crude estimates. And number two, the state was able to save money and say, okay, well, now we're not going to sit here for a year and just have a waterfall coming off the Sierra Nevadas. We're going to go in, we're going to remove the infrastructure, and we're going to put new infrastructure in. So that was helpful, and a lot more work has to happen there. We also worked with the town of Paradise because they had government buildings that they wanted to get back to use, and they didn't know how to test them. At the time, the state was telling them benzene's the only chemical that's present in the water. This town told me they didn't believe it, rightly so. And so we recommended what they do. They went in, they tested their buildings, and they found when benzene wasn't present, they had methylene chloride exceeding safe limits inside their buildings. So we gave them advice, and they followed it. We also helped the health department too, because they didn't really know how to test buildings as well. But one of the challenges here in the Campfire was that citizens weren't protected from contaminated water. The state told people to smell the water to determine if it was safe. I kid you not. And it's publicly information. It's publicly available. There were 2 water systems that had benzene contamination, and the customers were never notified. And I know that because there were communications between the customers and me. They were contacting me, and I was passing those on to the state. And when the state would be contacted by them and the state would respond, they would send me the communications too. So there were some customers that didn't follow the use restrictions. So I was told, I remember this conversation vividly. There was a 73-year-old man who called me and said, I'm using the water, I'm fine. In 70 years, if I get cancer, well, I'll be dead. So I don't care. And so, that was one perspective, but the other perspective was there was young families and, 1-month-old babies in the area. And so that's really who we're trying to protect with that guidance. For 6 months, the water was contaminated, and people were having contaminated water come into their building, and they were using it for things, not drinking, not cooking. But their infrastructure, their plumbing was contaminated, and they didn't know how to sample to determine when the utility said everything's fine now, the water's safe. The people said, well, what do we do? And they didn't have a method for figuring that out at the time. And then insurance companies were involved in making a lot of the decisions because the insurance companies didn't want to pay what's called ALE, additional living expenses. And instead of putting people up in a hotel, they said, well, we'll give you $3,000 to go buy a home treatment unit, and then you can treat your own water at home. But what they didn't tell you is that the treatment units are not designed for hazardous waste scale contamination. Treatment units are not tested against that. And as it turns out, some of the treatment companies that were installing devices thought only 1 to 2 parts per billion of benzene was in the water. That's what they were designing systems for. So in response to really the request from the public, we got together with a whole bunch of universities and community groups and conducted a survey, and then went into Paradise and try to help people better understand, how to test their plumbing, what it looks like, how to take samples and such. And, the survey that we conducted basically showed that the majority of people we talked to had some form of anxiety, stress, or depression associated directly with their water system. And much of it was because they didn't know if their water was safe or not, or their plumbing was safe, or if they could sell their home because their plumbing was contaminated. Many of the organizations didn't want to take responsibility. Nobody wanted responsibility for telling people how to test their homes. And so that was a problem. There was a high financial cost. Some people spent $3,000 out of their pocket to take water samples at their home. Some people were only testing for benzene one time at one location and assumed that because the state told them, that would mean that they never had contamination, they never will have contamination, even though contamination was still moving around the water system going into their house. And there was a tremendous amount of money spent on in-home treatment devices. Some other issues, commercial laboratories were offering their services. We will, analyze your water sample for benzene, $101. So we will give you these instructions. You take the sampling kit to your house, you do your own sampling and bring it back to us and we'll analyze it. Well, the instructions, some of them said, flush your faucets for 10 minutes before you take a sample. And so here's people that want to know if their home water inside their house is contaminated, and they're going to their kitchen sink and they're flushing their cold water for 10 minutes. So they're not sampling their house. Many people were ignoring, hot water systems. They didn't really understand plumbing design. We wouldn't go to, let's say, New York City and take one sample at one fire hydrant and say, clearly we didn't find anything, so the rest of the city is free of contamination. Homes have different pipes, they have different branches, they have different systems, and so you can't just take one sample and call it a day and know what's going on. So 7 months after the fire, we went in, but the state, the week before we showed up, issued guidance to homeowners. They issued policy that said, for 7 months, we said that you should do this for testing your home, and now we think that you should stagnate your water for 8 hours, and that wasn't adequate. And so a number of us at different universities got together and put in information. We tried to get this to the state, but they wouldn't communicate with us, and the reason is because they were trying to drop this information. Anyways, so the good thing is that there's great people out there, Jackson Webster at Chico State University, Charlotte Smith at UC Berkeley, and a number of other people at Butte College and elsewhere. We are able to come in, students, faculty, and staff, and kind of help people understand, how to take water samples, how to read a lab report, what to pay for, what not to pay for. But, really it comes down to policy. And so, Delaware Water Company found 530 parts per billion of benzene in their drinking water, did not warn their customers. Families used that contaminated water. One homeowner hooked up his RV. Delaware Water Company went out, did testing, and found contamination in the RV. And if you go to the US EPA's website, they have this thing called the public notification rule. And it implies, altruistically, that it is designed to help people know if their water is safe or not, and so they can get appropriate warnings. And to do that, you would have a tier 1 violation. You could enact it and say, we're going to follow the public notification rule. This will be a tier 1 notification. We need immediate notice within 24 hours. But there's no specific language that says under wildfire conditions or under hurricane conditions where you have chemical contamination in your distribution system, you must do this. This issue in California would fall under other violations or situations determined by the primacy agency, which means it's a gut call. It's a policy. And neither the California State Water Risk Control Board or the US EPA Region 9 chose to invoke the public notification rule, requiring the private water company to notify their customers that there was a risk to public health and prescribe water use restrictions. And so the policy was not to do anything. In-home testing was conducted by University of California at San Francisco 11 months after the fire. 11 months later, they found benzene in people's homes. They also found methylene chloride above the US EPA federal drinking water limit. They didn't do statistically representative sampling because they didn't have enough money, resources. They didn't test service lines. They didn't have money or resources. And just to kind of put on record, 3 months after the fire, we told the state what to do to figure it out, and they did not, chose not to develop testing method for people. So 1 year later, where was Paradise? They had a population of about 3,000. They were certified rural. They were no longer, an urban area. They only had built 11 homes a year later out of the 11,000 plus that had been destroyed. There was 7.3 billion pounds of debris, 2 times the World Trade Center amount after September 11th. About 50% of the meters and service lines where there was burned property, those were contaminated. And homeowners are pretty much on their own during this. So there are opportunities for the improved protection of public health. And you can find that in this National Academy Science of Engineering workshop report. It focuses a little bit on water, but also to, smoke inhalation, other types of public health issues. So now where are we today with all these fires? Well, there's many fires that have happened that are still going on. There has been contamination. So down in Boulder Creek, Boulder Creek, California, they found 42 parts per billion of benzene so far in the system. They came out and the utility and the state spurned the best available science and told people that they could bathe in the water without having any water testing data. So you remember Santa Rosa had 40,000 parts per billion of benzene in their water. In Paradise had over 2,000. And in the absence of data, the water's safe. That is policy. And once they found that the water was contaminated, they pulled back their bathing and told people not to bathe in the water anymore. And so I got contacted by a mother with a 20-month-old infant and a 4-year-old child asking me if it was safe. I told her not to, and the state came out later and said, yeah, don't bathe in the water. The Big Basin Water Company has contamination right now of 1.8 parts per billion of benzene and more chemicals. This doesn't mean the maximum amount that was ever present, because this is based on how well or how not well that they collected water samples. The Oregon fires are still going, and there's testing that's being conducted there. The County of Santa Cruz, after the CZU Lightning Complex fire, had guidance on how to do water testing after the fire. It was not good. They updated it to include VOCs and SVOCs, but they never included stagnation. So if you do testing, you may never find contamination if it exists. That's policy. There was no SVOC testing, and Oregon has now adopted California's policy. And so this document is available on their website. So all the mistakes that California made through policy potentially have the potential to perturbate through another state now. And, looking ahead, this is a statement from Gavin Newsom's California Water Board that just came out the other day. The Safe Drinking Water Act doesn't have a clause like this is what you do in a fire when a community is completely burned to the ground. And that's true, it doesn't. But what we need to do is start focusing on establishing policy based on evidence and science and being flexible to make decisions that best protect public health. Now, here's an example after the 2017 Hurricane Maria that hit Puerto Rico. What happened was the Puerto Rico Department of Health issued a boil water advisory because they lost pressure in their water system and the water may be contaminated with microbiological contaminants. US EPA also said, yeah, boil the water, which was good. On October 11th, though, the utility said that the water is basically safe. And on October 12th, the Department of Health said, because of just the difficulty with everything that's going on, we're going to stop testing until there's some stability. 2 months later, there was conflicting messages about water safety. And that is partly due to different agencies taking different positions and not necessarily working coordinated together on the messaging as well as what it takes to issue warnings to the population. So January 2014, there was a chemical spill, which I kind of alluded to before. 300,000 people were delivered black licorice smelling drinking water coming out of their faucets and their showers. The governor issued a do not use order. A chemical screen was not conducted. They just trusted the company to tell them what was in the water. The National Guard did run a test to prove that one chemical that they were told about was in the water. They told the CDC. The CDC did a risk assessment for that one chemical, didn't consider inhalation exposure, just what it would take to ingest it. And then 11 days later, that company that caused the spill said, oh, we've got to tell you there's these other things in the water. So the CDC then established new screening levels, but what happened after that was the utility told everybody to flush hot contaminated water out of their plumbing. to help get the contamination through, and that caused people to get sick. And that's policy. Now, these policies aren't well established, but they are established on the fly. And so really coming back to the question, after drinking water contamination disasters, is policy enough to protect public health? Actions and leadership are needed, and this is the last slide here. Decisions and public notification, mechanisms, all education and training is necessary. This is what will transform disaster response and public health protection. And I'm happy to work with whoever wants to do this, whether it be the state level, the county level, the local level, the utility level, the federal level, or wherever, because change needs to happen. Otherwise, these types of disasters and public health risks will be spread throughout the U.S. Indefinitely. Thank you very much, and I'm happy to take any questions.